think about where AI is deployed largely in these data centers, we're seeing lots of new projections come out around the scale and the increase in the energy consumption of just data centers, of which AI is just a part of it. And so one example is IDC has projected a 2x increase between 22 and 27. So that brings it up to almost, over 800 terawatt hours per year for data centers, a portion of which is AI. There is a Dutch researcher who recently published a projection bringing the AI portion up to 134 terawatt hours, which meaningful for his country is the amount of energy consumed by the Netherlands in a year. Yeah, it's really starting to grow at this significant scale. We did our own research with enterprise customers, and we asked them, how are you thinking about, these growing needs? And over 76% said, they're looking at AI, they're deploying the use cases, but then over 70% said that they're a little bit concerned about deploying this technology and their ability to meet their sustainability goals and commitments, and that the two are really in conflict. So when you step back and you think about that scale, a lot of what you're seeing in the news is around this massive consumption. Google's published a paper that today, I guess it was a couple of years ago, showed their AI use just in their regular search was 10 to 15% of their total energy consumption, and that represents 2.3 terawatt hours per year. Now you start to imagine adding Gen AI to every Google search, and it's going to increase dramatically. And when you think about ChatGPT, right, they're servicing 200 million subscribers a day, or 200 million requests a day, and what that has been likened to is the equivalent of powering 180,000 U.S. homes, and we're not the most energy efficient we know on the planet. And I always like to bring it back to us personally and individually. So what does that mean? If you're personally doing a query, it's the equivalent of charging your phone from 0 to 30%. If you're
every query that you type
for every query that you're doing. And then if you are generating an image, 0 to 100%. So just to put it in real terms for the energy cost.
And if you think about it, the way we use these is without any implication of what the costs are, because the costs are free to the consumer. And I mean, we generate, even just at Worth, we generate thousands and thousands of images.
Right.
And we only use one, the one that we take away.
Yep. There's always externalities to what we're doing, and I'm hopeful that over time, and actually even just yesterday, one of our partners, the Green Software Foundation, got something called the Software Carbon Intensity Metric into an ISO spec. So as you start to have common standards and methodologies about how to report this, I think we should all be expecting to see it so that you have that information in your own personal carbon footprint or your corporate carbon footprint.
Yeah, I was talking to a group of executives, and they talked about an AI project. Basically, AI has been thrown against every problem. Everybody's got a pilot program running, and they figured out it cost them $500,000 worth of compute to solve a $100,000 problem. And because there's no waiting. It's just when they're just throwing AI into everything. Obviously, that's something that probably can't continue and doesn't scale. Also because there's maybe not enough compute to solve, to scale in that way. But what is so Intel, obviously a company that builds these systems and enables all of these great applications. Mm-hmm. How do you consult with clients? How do you sort of fight it back against this?
Yeah, well, I think we look at managing the energy consumption of AI. So this is what we call sustainable AI. So as you're looking to deploy it, we see a couple of levers that can really help a company to optimize their energy usage. And the first is in the model optimization. And there's lots of things that a company can do in terms of modifying their algorithms, in terms of optimizing the software, compressing the model, using quantization techniques, reducing the amount of parameters. One study demonstrated that 99% of the data resulted in a null set. So you can really think about reducing the size of your model to meet your need. Intel builds software tools for developers, and we have an example of a neural compressor that helps to compress the models for inference, and it'll lower the size and increase the performance on CPUs and GPUs. So that's one area. The other is in software optimizations. We estimate that, over 30% of the cycles are due to inefficient software. So we really try to work at where the developers are in the stack and to optimize there. So we look at optimizing the platforms and the frameworks that are common, things like PyTorch, TensorFlow, Modin. So putting optimizations directly into those frameworks, but then also providing tools and toolkits like OneAPI, OpenVINO, as well as our Intel AI and Analytics Toolkit. And some of these enable a developer to have no code changes and to get the benefit, or even a single line of code change. One example in something that's called the scikit-learn function, when you update your code with that, they can get an 8x performance boost and an 8.5x energy reduction. So that really, I think it just demonstrates, one little change can have really dramatic impact. So you start to think about the performance per watt trade-off in that. It's very significant. Software is where we're going to see a lot of leverage. And then lastly, in hardware, how do you right-size it? How do you make sure that you're choosing the right hardware for your problem? I think today there's this race for the biggest, the fastest, which by definition is the most energy consuming as they get more powerful and more energy dense. And that might not be the tool that's needed for that job. And so, there's examples where, depending on the size of your large language model, less than 10 billion parameters, for example, you can run it on a CPU. If you have a CPU that has built-in AI accelerators, that really helps to, make that workload most performant. That's an example of right-sizing it. Excuse me. But also, when you're looking at hardware, like folks probably don't know, we actually have accelerators. This Intel Gaudi accelerator, it can deliver 2x the performance per watt of an A100, or a CPU our Xeons can deliver 2.2x over an EPYC. So really finding the right hardware for your workload so that you can operate most efficiently. And then lastly, you've probably heard us talk a lot about systems architectures over the last several years. And when we think about data centers and the amount of energy they're consuming, and here in the Valley, had some conversations with some of the large data center operators, as well as Silicon Valley Power and the California Energy Commission. There's no way to get more power here in the timely fashion that's needed. And so one of the tools to help dramatically lower the energy consumption is to move forward into those innovative spaces, right? And one of those innovative spaces is liquid cooling. This has been a mainstay in high performance computing that the professor talked about. We're sort of seeing this convergence of those two workloads together. And so what you're going to see is many more customers scaling.
So explain liquid cooling. I used to work at PC Mag. The hottest gaming rigs had liquid cooling running through it. It was very cool. I imagine you're talking about doing that on a data center scale.
That's right.
What does that look like? And then what happens to that heated up water? Can you then use that heat?
Yeah, it's a great question. So in terms of the energy reduction that you can be looking at, it's up to 40%. So this is material for any size customer. And, what it looks like, everybody's not building new greenfield data centers. So as they are, all of them are preparing for this at scale, because this is what will be required for the future. But in the brownfield, it looks like bringing in new facilities, new types of heat exchangers. There's many different types. I won't go through them all. Some of them are just direct to the chip, bringing the liquid over the chip, and others are fully immersing it. But to your question about the water, because you're now generating this hot water, you have the opportunity for energy reuse. And that's really exciting. And there's a lot of examples in Europe where they're using that for district heating. There's examples where you can put that to a greenhouse, right? Depending on where you're located. So you can start to have urban farms powered by a data center. And it enables you to put data centers in many different locations because in cases like immersion, you can handle some of the hardened environments that exist. So for like telecommunications, there can be dust or extraordinary heat or smog, those types of things. And so you can eliminate exposure to that as well.
So you brought up Europe, and whenever somebody does that on stage, I have to ask about the regulatory environment in the U.S. versus Europe. Are there, in terms of policies in governing these data centers and these applications, what does the U.S. look like compared to Europe? And are they the right policies? Do we need new ones to incentivize companies to consider their energy usage in a different way, other than just the cost?
So I think Europe's definitely leading in all of these spaces, and most recently, as far as data centers go, Germany put something forth called the Energy Efficiency Directive, and it actually enumerates a very long list of data that they want to start collecting from data centers. It's maybe not fully complete as it could be, so there's more that could be done if we as a society truly want to measure the externalities of understanding the utilization, the energy, that compute intensity per energy used. I think there's further to go. The U.S. doesn't have that level of requirements yet, but I expect we'll be seeing them soon.
Yeah. I think one of the challenges is that as we've moved to the cloud, back in the old days of PCs, you knew how fast your processor was, and you knew how much it could get done. You knew how hot it ran because it was sitting on your desktop or on your lap. Now you don't think about ChatGPT being a computer processing operation because you're so far removed from it, and you don't see the cost. You don't feel the cost in any important way. So in a lot of ways, we've got to create dashboards so people understand the true cost of things. But let's, AI, we've been beating it up, but there's also opportunities for AI to be part of the solution, like most technologies.
Yep.
Like, how do you see AI making things better?
So we see AI in those two regards, sustainable AI and then AI for sustainability. So on this second topic, there's just so much opportunity, right? The professor talked about a few of them areas for science. And I think that's one thing I want to start with is just when we look at AI in the future, we are seeing that it's going to be bimodal. And so what I mean by bimodal is every model isn't going to be 2 trillion parameters and growing. So there'll be those scientific discovery models on one end that are the largest in the world, and then there'll be enterprise AI models on the other side of that bimodal distribution. And that is really exciting to me because that gets back to those 3 areas, the levers that you have to improve the efficiency of your AI. And I'll just share one of my favorite examples is a company called Nature Fresh Farms. They have 250 acres under greenhouses, and they are a 25-year-old company. And they looked at AI and they decided to deploy 32 models on their 25 years worth of data. And they built on top of those models, they're feeding in real-time data, things like the moisture of the soil, the temperature, the humidity of the greenhouse. And by building that private enterprise AI model just on their data, and it's right-sized for their application, they are using it to then manage the lighting in the greenhouse, the ventilation, the power management of the overall solution. But most importantly, as we think about where the world's headed and the climate adaptations that will be needed, especially for food sources, they increase their plant yield by 3x. So that's more bell peppers, strawberries, all the great tomatoes that they're creating in their greenhouses. And on top of that, they use computer vision to package, like, I guess you would call it quality firmness fruits or vegetables. And when they do that and it's going out to market, you're going to get less spoilage and less waste. So it's just one of my favorite examples of using both enterprise private AI models as well as computer vision to reduce waste and increase plant yield. There's many other applications of AI for sustainability. At Intel, we're both a very large semiconductor manufacturer as well as a product design house. And we use AI on both sides. On the design side, we use it for the placement of the blocks to help ensure that we get the most power optimized chip at the end of the day. And then in our testing and validation, we use it to detect anomalies, and we also use it to reduce test time. Excuse me. I guess I did need that water, but I don't have a hand for it. So we've been able to reduce our tests by 60 to 70%. So you start to think about the business impact of that is we can bring products to market faster with less cost, and it reduces test time, which is energy consumption as well. So it's just a win-win-win and cost savings. And I guess maybe the last one I'll mention is, smart roads and smart cities, deploying AI to help manage traffic congestion. One of our partners, ISSD in Turkey, was able to reduce the carbon emissions in their city by 40% by deploying AI for traffic management. So these are just a few of the examples of smart manufacturing, smart agriculture, and smart cities. And how AI can really help us to achieve our sustainability goals.
That's great stuff. I want to give the audience a chance to weigh in here because I know they've got opinions about AI and sustainability. We've got a couple of mic runners that can hand those out. But if you've got a question, just raise your hand. In the back, the very back row, should be very close to the mics. Here we go.
And it's black out there.
Yeah, you can't see.
Maybe not. Okay. This is really cool. I feel like you talked about two different components of AI. One is the energy consumption, and then the other is the opportunity to reduce energy usage. Mm-hmm. And I was wondering if at Intel you've run any models to estimate sort of the return on investment or the cost-benefit analysis of how much energy AI could help reduce as opposed to the usage.
If you're talking about just within our own footprint, I would say the ROI is positive, right? There is no green premium. We are, whether it's building management, I like to joke, I think we've taken it too far because I'll be sitting in meetings and the lights go off. It's like they return to work hasn't changed the algorithm enough to recognize we're there. So in terms of applying it within our manufacturing and our operations, a huge ROI. I think what you're getting at is that larger handprint in the world, and that's something that we're partnering with academia, MIT, and some of our other partners to figure out what is the right way to quantify that impact, because we think it's very significant. And I know there's a lot of worries about Gen AI. I'll just go back to that building management because I think it's just such an easy one that for everyone to relate to. One of the companies I met who deploys energy management solutions for apartment buildings, they were able to scale their workforce and address more buildings and deliver more solutions where by using generative AI to create basically the sales pitch and the opportunity, instead of having to have an engineer build all of that themselves and take it to get that first sales call. So that's like a win-win-win on the ROI of generative AI, providing more jobs and deploying more energy management solutions across more buildings.
Yeah.
Yep.
We got another question right here. Do we have a mic right there? Oh.
Hi, thank you. Linda Kinney. Hi.
Hey.
I have a question for Jen. Given the increase in energy consumption of data centers and the fact that the hockey stick keeps going up, and we are in a situation where everybody's also going to need to charge their EVs, what are the companies doing to look at off-grid solutions to figure out how to use renewable energy in a way that's not going to tax the grid even more?
Yeah, it's a great question. And, the mix of, the audience today, it's really good to hear this as well. What we see, new clean energy solutions that are more energy dense are required for this future. And what is happening right now is I think there's a little bit of a lack of a market demand to get the investment to get over the chasm. So that's something that we'll be, addressing with our community. We just held a sustainability summit a week or two ago with our whole supply chain and our customers, the whole value chain. Energy is the number one thing we need to solve for wherever compute is used to deliver sustainable compute for a sustainable future. But then on top of that, how do you how do you help support the utilities to upgrade and modernize what they currently have as a one-way load to be able to handle that two-way load? And technology can actually be deployed there as well. So when these off-grid, if you will, energy units are deployed, they can also be fed back into the grid, and there's technology solutions that exist to basically modernize the grid and the secondary substation so they can handle that two-way load, and those exist today. So, great question.
Perfect. Well, we're going to have many more questions. You're going to be with us for the whole day, so we can continue this conversation, but thanks so much for coming on the stage.
Thank you, Dan.